Hello, this is Mrs. Johnson. This is MAT221, Calculus 1. We're in section 5.2. We were talking about this expression on Mathematica, and we were looking to determine what the values of A and B were from our PowerPoint. So what we tried to do is I tried to solve where is this function equal to 0 to find out this 0 right here. And it gave us this crazy expressions here. Those are crazy. So when this happens often, especially with trig functions, because remember trig functions are periodic, so they'll have multiple roots throughout the whole, infinitely many roots throughout a function. So what we usually do is say, okay, I want to find the root right here. This looks like 1.5, 1.6, 1.7, 1.8. So it's about 1.7 or 1.8. So I said, I used the find root command. So I said, okay, find the root that is equal to 0 of x near 1.7, and so Mathematica gave me, okay, it's that root right there is 1.77245. All right, once I do that, I'm going to have Mathematica find the integral from 0 to that root. So I did that here from 0. I just grabbed it. Believe it or not, it'll take as many. If I just grab, go like this and do Control C to copy it, it'll grab all those values there. So I'm like, okay, Mathematica, what is the integral from 0 to that value of this function? And it gives me 0.8948. So this area underneath the curve between 0 and that value of about 1.77 was equal to 0.894831. And then, so that would be the value of A. And then I asked Mathematica to find the value of B, which is from that value to the end, and it was negative, which as we expected it to be because the area is below the x-axis, so I should get a negative value. And of course, the integral from 0 to radical 2 pi should be those two numbers added together, and there's my value. So let's go back to the PowerPoint, and now that we've looked at Mathematica. So let me bring this over for a second. Let me go back to our PowerPoint here so we can see. So yep, we used the calculator. Actually, we used Mathematica here to find the area A was 0.8948. Area B was 0.4641, but negative. So adding them together, we would get 0.4307. So again, those numbers were all found using technology. All right, so what would be the total area of the region bounded here? Now, the total area would be area A plus area B in this particular case. So when I would do this, it would be the integral from 0 to that 0, which was that x-intercept there, which was 1.77 or so. And then I would subtract this integral, or in other words, add the absolute value of this integral to get that actual value. All right, so our last thing that we want to talk about in this section of the unit is our book gives us rules for working with integrals, and the most important of them are these particular rules. If I have a definite integral from a to b of a function, f of x dx, and I reverse the bounds. Notice I'm reversing the bounds. When I reverse the bounds, I reverse my direction, and therefore my integral then changes sign to a negative. So reversing the limits actually changes the sign because we're technically changing the direction in that we're looking at the function. The second rule is kind of common sense. It says if I take the integral from a to a of a function, obviously, I've started at A, I ended at A, I didn't go anywhere, so there is no area underneath the curve, so that integral is equal to negative. So if the upper and lower limits are equal, then the integral is 0. Property number 3 is called the constant multiple rule for integration. If I have a constant multiplied by a function, that constant can get pulled out to the front, and then I can take the integral, the definite integral of the function. So I just pull the constant out to the front and then take the definite integral of the function. It's called the constant multiple rule for integration. Rule number 4 is the addition rule. This also works with subtraction. If I take the integral of the sum of two functions, that is equal to the integral of the first function plus the integral of the second function. It's called the addition rule. The subtraction rule also works. Rule number 5 is the one we kind of looked at earlier, that if I take the integral from a to b of a function, and then take an integral from b to c of that same function, and b lies between a and c, then this will be equivalent to the integral from a to the integral to c. So intervals can be added and or subtracted. So if I want the integral from a to b, and then the integral from b to c, then that will equal the integral from a to c. Rule number 6, again, I'll try to describe this one. We don't use this one that much, but every once in a while it might come into play. The definite integral from a to b of a function is actually somewhere between less than or equal to the minimum of the function over the interval and the maximum of the function over the interval. In other words, if you take a function from a to b, f of x, here we go, right here, you can see it. The maximum value of this function, the minimum value of this function is right here at x equals a. And the rectangle, or the area of the minimum value over this interval, would be this particular rectangle, right? That would be the minimum value of the function, would be the height of that, or the length of that rectangle, and the width of the rectangle would be b minus a. So that would be that area right there. So here we have the maximum value of the function over the interval from a to b. That will be that value, that area. So what is this saying? This is saying that the area from a to b is somewhere between the minimum value over the interval and the maximum value over the interval. So the area from a to b is somewhere between those two rectangles, which makes sense. All right, let's see if we can use some of these properties, if we can find this. It says, suppose we know this information. We know the integral from -1 to 1 of f of x dx is 5. The integral from 1 to 4 of f of x dx is equal to -2. And the integral from -1 to 1 of h of x is equal to 7. So let's see if we can calculate the following values, if possible. Find each of the following integrals if possible. All right, so let's look at part A. Part A says, if I want to know the integral from 4 to 1 of f of x. Well, I was given right here in the second suppose here, I was given the integral from 1 to 4. So if I change my bounds using my rules, it would then change the sign of my integral. So what was a -2 will now become a +2 because I've now inverted my bounds or changed my bounds, which means I've changed direction. Part B says, can we find the integral from -1 to 4 of f of x dx? Well, I have the integral from -1 to 1, and I have the integral from 1 to 4, and we said if the upper bound of one integral of that function is equal to the lower bound of another integral, we could add them together to get the integral from the lower bound of -1 to the upper bound of 4. So adding these together, we would get 5 plus a -2, I'm sorry, the notation is wrong there, plus a -2 would equal 3. Part C says, could I find the integral from -1 to 1 of 2 times f of x plus 3 times h of x? Well, yes, I can, because using a couple of rules here, pulling out the constants and then distributing the integral, I get this would be 2 times the integral from -1 to 1, which we know is 5, plus 3 times the integral from -1 to 1 of h, which we know is 7. 2 times 5 is 10, plus 21 will give me 31. Part D says, can we find the integral from 0 to 1 of f of x? Well, let's see. If I look at this first one, it seems as though I should say, well, from -1 to 1 and going from 0 to 1, that's halfway across. But we cannot make that assumption. We can't assume it's half of 5, which is 2.5, because we don't know what this function f looks like. F may be going up, tremendously from -1 to 0, and then just going down a little bit from 0 to 1. We don't know what f is looking like. So we don't have enough information to answer this particular scenario. Part E says, how about h from -2 to 2? Well, we know what h is from -1 to 1 is 7. And of course, we want to jump in and say, well, this is doubling that, so this should double 7. But we cannot make that assumption. We don't know what happens on the h curve from -2 to -1 or from 1 to 2. We don't know what's happening. All we know is that this integral is 7 from -1 to 1. So again, I don't have enough information to answer that question. And then lastly, in part F, it asks from -1 to 4 of f of x. Okay, we already found that one. That's right here. We know that's going to be 3. And then from -1 to 4 of h of x. Well, we know from -1 to 1 for h of x, but we don't have any information of h of x from 1 to 4, so we can't complete the second part of this integral. So again, we don't have enough information. All right, you definitely have a web assign on this section, on section 5.2, dealing with the definite integral as area and properties of integration. Have a great week.